Hey, Algebra 1 students. This is a video for Lesson 8.4, Check for Understanding. I'm just going to go through Example 1. Now, if you remember in class, this is that new form that we discussed yesterday. And the way you can tell it's that different form is you have these parentheses and the squared outside of the parentheses. If you think about all the other examples of quadratic equations that we have been looking at, they looked something like that, where the squared was right on the x. When you're in vertex form, so that's the first thing we're going to put here. This is vertex form. We have those parentheses and the power of 2 or the exponent of 2 outside the parentheses. Now remember, we said numbers in the parentheses. In the parentheses is the bizarro land, so numbers in the parentheses are going to be the opposite of what they appear. And then the number on the end, the +2, is just exactly like it appears. So a right-left or a horizontal translation would be happening if you have a number inside the parentheses with the x. And a vertical translation would be happening with your number hanging on the end. So this example right here has a horizontal translation of 5 to the right. So I'm going to go right down to the bottom and fill that in right now. Horizontal translation, 5, that's the number, and it's moving to the right. So it looks like -5 when you look at here, but remember inside the parentheses we said it's bizarro land and it's going to do the opposite. So 5 to the right. The number at the end, always in this form or this form, the number at the end is a vertical or a up-down translation. So this parabola is going to move to up. So vertical translation, the number is 2 and the direction is up. Okay, the other great thing about vertex form, if you remember, this 5, 2 is my vertex. So my vertex is 5, 2. So if you had a parabola in standard form, or the parent function of x squared, so remember the parent function of x squared has its vertex right there. The vertex would move 5 spaces to the right, 1, 2, 3, 4, 5, and 2 up, 1, 2. So that puts your vertex at 5, 2. If you have a vertex with an x value of 5, then your axis of symmetry is x equals 5. Max or min. This vertex form has an a value that's right in front of there. We don't have a number in front of the parentheses on this one. So the a equals 1. So remind yourself that if a is positive, that means you have a smiley face. And if you have a smiley face, you have the bottom of a roller coaster. So you have a minimum. All right, and where is that minimum going to be? It's going to be at the vertex, the y value of the vertex. So I want you to add the word here, value. So we're going to find out where the minimum is. It's going to be at the vertex. It's actually going to be at 2. So we'll write that in right now, and then I'll point it out after we graph it. All right, so if our vertex is 5, 2, we want to put that right in the middle of our table of values. Okay, the function that we are graphing is this. I'm just copying that from right here. And my x values, remember, I want it to be right around 5. So if this is 5, I want to find a coordinate point at 6 and 7 and 4 and 3. I'm gonna graph that vertex right now. So over 5, 1, 2, 3, 4, 5, up 2. I'm also going to draw my axis of symmetry. I know because A is 1 that this is upward facing, so I'm going to get those other points. When I'm done, I should have 5 points. So for 3, what I want to put in the calculator, instead of x minus 5, I'm going to put 3 minus 5 parenthesis squared plus 2. So let's show you exactly how we're going to punch that in. Hopefully this shows up okay. Yes, it does. So I'm going to put in left parenthesis, 3 minus 5, right parenthesis, squared. Don't forget the squared. That's probably the most common mistake. Plus 2, and I get 6. So this equals 6. Now, when x is 4, I'm just going to show you this on the calculator. I'm going to replace that 3 with a 4. So I'm going to arrow up, arrow over, and make that 4. And then I get 3. When x is 6, I'm going to replace that value with a 6. So instead of x minus 5, I'm going to do 6 minus 5, enter, and I get a 3. And remember, that's normal. Because parabolas are symmetrical, these two y values should match on either side of the vertex. When I put 7 in, I should get 6. So let's check that. Let's put 7 in. There we go. And I get a 6. Okay, now let's graph these points. So this is the coordinate point over 3, up 6. So I'm going to go over 1, 2, 3, up 1, 2, 3, 4, 5, 6, put a point. Now remember, these are symmetrical. So if I have a point that's 2 to the left of the axis of symmetry at y equals 6, I'm going to have another point that's 2 to the right of the axis of symmetry at y equals 6. That's this coordinate point right here. 1, 2, 3, 4, 5, 6, 7, over 7, up 1, 2, 3, 4, 5, 6. So that's this coordinate point right here, 6 and 6. All right, so I graphed over 4 up 6. Now I'm sorry, I graphed over 3 up 6. Now I'm going to graph over 4 up 3. So 1, 2, 3, 4, up 1, 2, 3. And I'm going to also graph over 6 up 3. It's going to be symmetrical to this point. 1, 2, 3, 4, 5, 6, up 1, 2, 3. Okay, there's my 5 points. Nice smooth curve, no corners, please. No sharp corners, nice rounded corner. Okay, now when I look at this, remember domain is x's. This parabola is going to the right and left forever, so domain is all real numbers. You can use that symbol for all real numbers. Range is y's, so I want to put a y, and then I want to find where in this case, the bottom of my parabola is. So the bottom of my parabola is at this y value, which is 2, which makes sense because the y value in my vertex is 2. So I'm going to put a 2 here. And then this is the bottom of a roller coaster. There are no y values less than 2. 2 is the absolute bottom or the smallest y value. So I want to put the little tiny point by the 2 and add the equal to. All the rest of the y values are above or greater than 2. Okay, we've done just about everything except this. Circle these other transformations. Now, all of these transformations come from your A value. Remember, if A is negative, then you have a reflection. If A is greater than 1, then you have a vertical stretch. This is in your notes. If A is between 0 and 1, then you have a vertical shrink. And those are what we called, remember, numbers on the measuring cup. Measuring cup, trying to squeeze that in. All right, so when we go to this equation up here, I said that this was our A value. We didn't have a number in front of the parentheses, so that means it's an invisible 1. We said our A was 1. If our A is 1, we don't have any of these things happening. A equals 1. So A is not negative. A is not greater than 1, and A is not less than 1. A is equal to 1, so this is no, this is no, this is no. Okay, so that should help you get through the rest of this paper. Just to point out the difference between this equation and this equation has an A value. So when you do example 2, you might want to start out by writing A is negative 1/2. That's your A value. That's it.